The electrical system provides electricity to all electronic systems on an airplane, including essential components such as landing gear, flaps, and cockpit instruments.
A diagram of a basic aircraft electrical system can be found in Chapter 7 of the Pilot's Handbook of Aeronautical Knowledge. The electrical systems of the majority of planes use a 14 or 28 volt direct current system. Here is a basic explanation of the essential components of electricity. The symbol for amps is capital A and the symbol for volts is capital V. Let's explain this with a simple analogy of water in a pipe. Let the water represent the electrons or electricity flowing in a wire. The amps are the size of the pipe that the water is flowing in. If the pipe is bigger, then the amount of water that has the potential to move is bigger. Note that the current is not the size of the wire being used. Subsequently, the amount of water is useless unless you have a force to push it. This is where volts come in. Voltage is, in this case, the force of the water being pushed. A large amount of water being pushed slowly out of a big pipe is theoretically the same as a small amount of water being pushed quickly through a small pipe. So if you push a large amount of water at a certain speed and a small amount of water at the same speed as the first, the bigger pipe will have more electricity flowing out.
The capacity of a storage battery is measured in amp hours. 1 amp hour is defined as a current flow of 1 ampere for a period of 1 hour. For example, 5 ampere hours indicates a current flow of 1 amp for 5 hours. The capacity of a battery is usually based on a given discharge rate, since the capacity will vary with the rate of discharge. The capacity of an aircraft's battery is usually based off of a 1 hour discharge rate.
The essential components of the electrical systems of a fixed-wing aircraft are the alternator, the battery, the master battery and alternator switch, circuit breakers, a voltage regulator, an ammeter and a load meter. The alternator is the main source of electricity for an aircraft. Like a car, it uses the engine's circular motion to make electricity. It constantly powers all components and charges the battery simultaneously. Alternators generate alternating current, which is immediately converted to direct current to be used in the electrical system. The alternator's output remains relatively constant throughout all engine speeds. The electrical system is powered on or off with a master switch. When the master switch is turned on, it provides power to all circuits except for the ignition system. The battery switch activates the electrical system so that the battery powers it. The alternator switch controls whether or not the pilot wants the alternator to be a part of the circuit. A pilot may turn this off in the event of an alternator failure. In this case, the entire electrical load is placed on the battery. It is advised that all non-essential electrical equipment should be turned off to conserve battery power. The battery can be charged by the alternator or by an external ground power unit. The main use of the battery is to start the engine ignition. The battery is also used to power systems when the engine is not yet turned on. A pilot must be wary of battery capacity as it is severely reduced in cold temperatures experienced in harsh climates or in the sky. Circuit breakers are used to protect the electrical system from power surges and to prevent electrical fires. Circuit breakers replace fuses that used to be used on aircraft because when fuses blow, you must replace them to complete the circuit again, while with circuit breakers, you only need to press a button to once again complete the circuit. Circuit breakers are grouped together on buses. Buses group different components together that use similar amounts of electricity. For example, there is a primary bus for essential equipment such as lights and flaps, and there is an avionics bus for computerized instruments in the cockpit. Planes may have one or many buses. The power in a bus must be controlled strictly to prevent accident. A voltage regulator regulates power in the buses. A voltage regulator and alternator control unit are used to monitor and control the electrical system. A voltage regulator allows the power generated from the alternator to charge the battery and power the electrical system with a safe, usable voltage. The voltage regulator also stabilizes the output of the alternator. A pilot must closely monitor the performance of the electrical system. The main components for this task are the ammeter and the load meter. The ammeter shows electrical performance of the electrical system and alternator. For example, if the alternator is charging the battery and providing sufficient power to the electrical system, the ammeter will show a positive charge. If the alternator is not charging the battery, or if the alternator fails to provide power to the electrical system, a negative value will be seen on the ammeter. A zero indication on an ammeter indicates that the battery is neither charging nor discharging. The load meter shows the load being placed on the alternator. If the alternator load is 25 amps, then the load meter shows 25 amps. If the load meter is on zero, the alternator has either failed or is not currently being used.